Hello, this is Maureen Ringrose, and we are back at it again, working on our geometry skills. This chapter is all about right triangles, and then we get to go into right triangle trigonometry. It's going to be so much fun. So this one, sorry I don't have the objective listed on this page. It's part of my entire unit plan. This one I want to make sure that you guys are able to use the Pythagorean Theorem to find missing sides of triangles. So some of you guys are absolutely well versed with the Pythagorean Theorem, so this video might be one that you wouldn't need to do, or if you just want to scan over it to make sure that you can do all the things I expect you to be able to do. But if Pythagorean Theorem is not a strong suit for you, then you definitely want to watch this video and take very good notes. All right, before we can use the Pythagorean Theorem to find sides that are missing, we need to first be able to identify the sides of a right triangle. So in any right triangle, we have something called the hypotenuse, which is defined as the side opposite the right angle. It's also the largest side. And if you recall your triangle inequality theorems, the largest side of any triangle is going to be across from the largest angle of any triangle. And in a right triangle, the right angle is going to always be the largest angle. So, and if you have difficulty identifying the side that's opposite, what I would recommend you do is put your pencil on the right angle and draw a ray that crosses the triangle, and the side that that ray touches is considered your opposite side. So I'm going to label my triangle hypotenuse. Okay. Next, we need to identify the legs. The legs are the sides that form the right angle. All right, so we also call this adjacent. All right, adjacent is super important geometry vocabulary. So because this side touches the right angle and this side touches the right angle, these two are called the legs. All right. So now that we can identify the legs and the hypotenuse, we're going to get into the Pythagorean Theorem and then start using it. The Pythagorean Theorem states, for any right triangle, the sum of the square of the legs is equal to the square of the hypotenuse. So that means a squared, if a is a leg, plus b squared, if b is a leg, equals c squared, which is my hypotenuse. Okay, so I have my nifty little graphic there just to illustrate that, if a side is 3 boxes, 3 squared is 9. If another side is 4 boxes, 4 squared is 16. And they're going to add up to 5 boxes squared. All right. So then we're going to use Pythagorean Theorem a lot to be able to find the missing hypotenuse or missing leg. But again, you need to know what it is that you're finding so you can set up your equation correctly. So in the example on the left, the x that I'm going to solve for is across from my right angle. So that means it's the opposite, which means it's my hypotenuse. So if I'm going to start with my formula and then substitute in 8 squared plus 6 squared equals x squared, I can go ahead and solve that. So the first thing I would do is to simplify my exponent terms. Add those together, and then take the square root of both sides, and our final answer is x equals 10. Right? The example on the right, n looks like it's in the same spot as x, right? It's in the upper right hand side there. However, the triangle is rotated, and you'll notice that this n that we're going to have to search for is on a side that is adjacent to my right angle. So on this equation, you want to set it up as 7 squared plus n squared equals 15 squared. Again, n is a leg on this right triangle. So 49 plus n squared equals 225. Then I'm going to subtract 49 from both sides. I get n squared equals 176. And when we take the square root of both sides, I get that n is approximately, what was that, 13.62 maybe? Something like that, 13.6. You can tell me if I'm wrong tomorrow. All right. Then we're going to move into some common word problems with the Pythagorean theorem. The first one describes a 16-foot ladder that rests against the side of a house. So that's going to create a right triangle. So let me draw my house. Hopefully your house is straighter than that, and it is at a right angle with the ground. And then you have a ladder that's resting against it at an angle. And you're told that the ladder is 16 feet and that it is 4 feet away from the house. So now that you have your measurements in there, hopefully it's obvious that you're searching for a leg. And that when you set up your equation, it's going to be 4 squared plus x squared equals 16 squared, right? And I have all my squares memorized, so this is, easy math for me. Subtract 16 from both sides. And to solve this, we're going to square root both sides, and you get x equals approximately 15.492 feet. All right. Make sure you ask me some questions if you are not sure how I got through that problem. Next one is is looking for the area. So we're not just looking for a side, but we're going to need to use the Pythagorean theorem to get that information to use my area formula. Remember, the area of a triangle is 1/2 the base times the height. So let's see what I have. I'm going to draw it first. This looks like an acute isosceles, right? And the base is 10, and my legs are 13. Now, hopefully you remembered when we talked about the special segments of triangles. If I were to draw a height or altitude from my vertex angle down to my base so that I can use the Pythagorean theorem, and I need the height for the area formula, in an isosceles triangle, the height is also the median. It's a special property we explored for equilateral triangles and isosceles triangles. So now what I can do is know that this is a midpoint and divide 10 by 2 to get that both of these sides are 5. So sometimes it's helpful to redraw the part that I'm looking for. And I'm going to employ the Pythagorean theorem on just this part. Actually, I'm going to erase that x, if you're okay with that, and put an h for height. So you're going to go ahead and finish this problem up. Look for the height. Once you get the height, you're going to plug that into the area formula. So it's 1/2. My base is still 10 because we're using the base of the whole triangle. And then, times your height. And you get an answer. Okay, and then the last thing I just wanted to draw your attention to, this is all on you if you want to memorize some of these. These are the Pythagorean triples that we've mentioned. And a Pythagorean triple are integers, so they're whole numbers that fit the equation a squared plus b squared equals c squared. And there's an infinite number of Pythagorean triples in existence, but there's very specific ones. So the common ones you should definitely memorize are 3, 4, 5. And then my brother's wedding anniversary, May 12, 2013. And then the other two that are pretty common, there's a lot of other ones, but these are probably the most common you're going to see. And then, of course, all their multiples. So if we used a scale factor of 2, then the 3, 4, 5 triangle is now 6, 8, 10. If we had used a scale factor of 3, it's now a 12, 9, 12, 15. All right, so hopefully that makes sense. And this is on you if you want to go ahead and study some of these. It certainly makes your life easier. All right, and so the next video is going to be about using the Pythagorean theorem converse. I hope this was a helpful refresher or review on Pythagorean theorem. You're going to have some classwork to do to show me that you are experts in Pythagorean Theorem. So as always, if you have any questions, please let me know and I will do my best to help you out. Have a great day.